So theory is all well and good, but if we're going to invest money in trying to limit CO2 emissions to avoid climate change, really we want something more. We want to have evidence that everything is working the way it is thought that it should theoretically. So the way to do that is to see if the Earth is in fact warming up. There are three different sort of major types of temperature measurements: those over land, those over sea, and those from satellites. Land temperature records go back to the invention of the thermometer by Gabriel Fahrenheit in 1714. The thermometer is very easy to calibrate because you can just stick it in boiling water and then stick it in ice water and make a scale between those two things. And since we know today what temperatures ice melts and boils at, it's very easy to interpret very old thermometer measurements in terms of what the temperature really was. This is as opposed to, say, measurements of CO2 concentration or something like that that would have used methods that are hard to reconstruct today. And so, you know, some kinds of old data are really not worth that much. But old temperature data is pretty reliable. So one possible problem with the land temperature measurements is called the urban heat island effect. This is a very real effect. The idea is that in a sort of vegetated landscape, the incoming sunlight energy can be carried back away by the latent heat in water vapor, because plants mine water from the ground and they encourage it to evaporate. Whereas in a sort of urban landscape, the same heat input can only be balanced by warming up the ground enough so that infrared energy leaving can balance the incoming light. And so in maps of temperatures or infrared images from space of around cities, it's very clear that it's warmer in urban environments than it is in rural environments. So the problem would come in if a lot of the places where they measure temperatures have transitioned over time from relatively green places like this to relatively urban places like that. And if you then took the warming that would be due to the urban heat island effect and you called that global warming due to rising CO2 concentrations, that would be a wrong attribution. But there have been many studies that have taken the thermometer data and put them together into the global average temperature change. And they take different methods of trying to filter out the urban heat island effect from their averages by taking stations out if they seem like they're likely to be a problem. And as you can see in this plot, basically everybody's getting the same answer for the average temperature of the Earth. So it turns out that the urban heat island effect, while it is a very real effect, is not an important one for setting the global average temperature. So it's not confounding the global warming signal that's being measured by thermometers on land. A different way of measuring the temperatures is over the oceans. And this is good because it doesn't have any possibility of an urban heat island effect, and so it's a separate sort of a check. But there has been a change in the way that temperatures have been measured at sea over time. In olden times, they would cast a bucket over the side on a rope and then pull a bucket full of seawater on deck and stick a thermometer in it. And this had the possibility of bias because water on the outside of the bucket could evaporate and could cool that bucket down just a bit relative to what it was in the actual water that the boat is floating in. And then sort of in the mid-40s, there was a transition in the sea surface temperature data toward measurements that were made on the cooling water intake to the engine. So they have to bring water in to cool down the engine as it's running. You measure the temperature as the water comes in before you've dumped heat into it, and that can tell you a sea surface temperature. Of course, this cooling intake might be coming in from a little bit below the surface. It may not be exactly the same temperature as here. So to put together the land and the sea surface temperature records, you can't just compare them directly because they're kind of apples and oranges. The land tends to heat up more than the ocean would for kind of the same reason as this urban heat island effect. The ocean would be like a super vegetative place with lots and lots of capability for water vapor to carry away heat. And also the ocean is a big heat sink itself. And so the land surface is actually expected to warm more quickly than the ocean surface for those reasons. So the way to compare, these apples and oranges is within a climate model where you impose the temperature at the sea surface from the measured ship data, and then you use the model to predict the temperatures in the atmosphere, both in the air just above the water, but also more importantly over the land. And then you can compare these model predicted land temperatures with the actual temperatures measured at those weather stations. And it turns out that there was a significant correction that had to be made between this technique of measuring sea surface temperature in buckets versus measuring the sea surface temperatures from the cooling intakes. But aside from that, the temperature signals that come out from this are consistent with those from after that correction is made. Both the land and the sea surface temperatures are telling us the same thing about the temperatures of the Earth. The third way of measuring temperatures is by satellite. And at first blush, this would seem like it is the ideal way of making measurements because it's out in space and nobody's touching it and it's covering the whole world. It's actually not the best way to get a time series measurement of temperature because orbits of the satellite can decay. And over the time span that we're talking about, there were several satellites that flew. And so they all have to be calibrated against each other in order to come up with a time series. So the satellite is really good at making a map, an instantaneous snapshot of surface temperatures. But for a time series, it's a bit more work. And for a long time, the satellites didn't show the same warming as the land and the sea surface temperature records were showing, and so this seemed like could be a major problem. It turns out that so the way the satellites work is they measure microwave radiation that comes from molecular oxygen, and just like greenhouse, blackbody radiation, these wavelengths of light are more intense when the oxygen is warmer. The difficulty is that the satellite is sensitive not just to the temperature right at the ground, but it's sensitive to temperatures throughout a range of altitudes in the atmosphere. And so if there's cooling higher up, that can pull the temperature the satellite sees down. And so you don't get the full signal from the ground, which is what we're interested in. So after the latest round of corrections, you can see in this plot that the satellite temperatures, although very spiky, are also consistent with the land and sea surface temperature records, and that they show this warming in the last few decades that will turn out to be the smoking gun for a human impact on Earth's climate. So if we want to attribute any changes in temperature that have been measured by these various techniques to a human impact on climate, we need to compare the measurements to what the climate models predict. And this is what the comparison looks like. The solid line here is the global average composite temperature that has been measured. And then there are two different fields plotted along there. The one in sort of salmon color are the result of climate models that have been driven with human climate forcing and also natural forcing. So the human forcing includes the greenhouse gases, methane, CO2, other greenhouse gases, and also the cooling impact from the sulfate aerosols, which is actually more uncertain than the greenhouse gas warming, but put all that together. And then the natural forcings are volcanic eruptions that put aerosols in the stratosphere and tend to cool things down, and any variability in the intensity of the sun can also impact Earth's climate. So you put all that together and drive a climate model with it, and it can reproduce this warming of temperatures since about 1970. Whereas if you run the same models and you tell them only about the natural climate forcings, the volcanoes and the intensity of the sun, the models don't get that warming since the 70s. So that's it. That's the smoking gun. That's the smoking gun for a human impact on Earth's climate. So one perspective on this was a fairly nasty quote that climate scientists blame CO2 because they can't think of anything else. And it's totally true that there are all kinds of things that could surprise us in the Earth's climate system. It's a very complicated and subtle thing, and we certainly don't know absolutely everything. So some examples of processes that could have caused that warming that we might not be able to detect include maybe there was a change in the rate of cosmic rays hitting the atmosphere because we're in the change in the shielding of the Earth by the magnetic field of the sun, for example. Cosmic rays could act as cloud seeds, the same way that they used to use cloud chambers at particle accelerators. A ray would go through and the air is super saturated in water vapor, but it doesn't have anything to condense on, and so it just stays in the vapor phase. But then when the cosmic ray goes through there, the particle goes through it, it makes a track, actually, of little cloud particles. So maybe something like that changed the cloudiness of the planet in a way that would be hard to detect. And it's very hard to model clouds, as you remember, because the processes that control them are taking place on a spatial scale, which is much smaller than the grid resolution of the climate models. Another possible effect is that when the sun gets brighter and dimmer, most of the change in the intensity of the sun is not in the visible light that we can see, but it's actually an ultraviolet light, which doesn't just come down to the ground and put its heat on the ground surface like we've been talking about sunlight. It gets absorbed in the upper atmosphere. It produces ozone, which is an oxygen molecule with 3 oxygen atoms, which is a greenhouse gas, and it's very important for determining the way that the air in the stratosphere, in particular where this ozone is, circulates. And so ozone is a very fundamental player in the atmosphere. So, what about these things? Maybe this is what's going on. Well, the way I like to think about this is in terms of sort of a murder mystery. So say you walk in and you catch the butler, and he's got a smoking gun in his hand, and there's a dead guy on the ground, right next to him. And so it looks to all the world like the butler did it. And it's a really important case, and so you check and you make sure, it's the butler's gun, he's got his prints on the gun, and you know why he did it, and it all sort of checks out and makes perfect sense. You got to spend all your time writing these silly reports to keep your boss happy, right? But say your partner is kind of a contrary kind of a guy, and he says, no, I think the chauffeur did it. And I think you're just not smart enough to figure out how the chauffeur did it. And you check it out, and it doesn't seem like he did it. He's got an alibi, he wasn't there. But it is very hard to prove a negative. But the point is that if you wanted to convict the chauffeur of that murder, you'd have to unconvict the butler. You'd have to explain what the butler was doing with that smoking gun in his hand. So translating out of this somewhat tortured analogy, if you want to claim that the warming since the 70s was caused by cosmic rays or something like that, and not caused by rising CO2 concentrations, you would have to explain why the rising CO2 concentrations would not lead to the warming that we expect. The climate sensitivity of the Earth, how much the Earth should change for changing CO2, is a fairly well-constrained parameter. And if you want to throw that out the window, you have to explain why. So there are no climate models that don't predict a significant amount of warming if the CO2 concentration continues to rise. The only sort of climate denier position is to say, well, what about this? What about this? You didn't think about that. There's not a substantive model that can explain the way the Earth works today that doesn't predict that it will warm up significantly with rising CO2 concentrations. So it looks to me like the chauffeur is fairly safe.